Making this recording for anyone who can't make it to class today. Today we're going to be going over ethics and the use of technology. So one of the key things we need to go over as we go through all the rules that we've gone over up to this point, needing to be reliable and trustworthy and honest and treating people with humanity and trying to be utilitarian and having some virtue, that all still applies. That's all still important. Just the nature of the beast has changed. So the demon in the room now is electronics, artificial intelligence, computers. You just need to pay attention to how they work and all that jazz, but all the old rules still apply. All right. Engineers in the fulfillment of their professional duties shall hold paramount the safety, health, and welfare of the public, perform services only in areas of their competence, issue public statements only in an objective and truthful manner, act for each employer or client as a faithful agent or trustees, avoid deceptive acts, conduct themselves honorably, responsibly, ethically, and lawfully, so as to enhance the honor, reputation, and usefulness of the profession. Okay. So what's going on with technology is very interesting across the board. There's a few generic rules that have been coming around, but basically the processing speed has doubled every 10 years. Very interesting. As of right now, a lot of people would argue computers are as smart as we are. They're not as creative. There's certain tasks they still can't do, but with the introduction of AI, there's a lot they can do. And you're going to find that a lot of the scut work that you used to do or had to do, the AI will do for you. It will write a lot of your reports for you, which is nice. However, you still need to understand what the computer is doing and why it's doing it that way. This is just the history of computers. UNIVAC was probably what we would understand as the first computer. And people are guessing it's going to lead to the computer singularity at some point, but I don't know if that's something we need to worry about. So this technology has been on the rise. The first world more or less transitioned from analog to digital in the late 2000s. So instead of receiving letters and telegrams, you would get emails and instant messages. You'd get information. Getting information used to take days, and now it takes seconds. Sometimes it's instantaneous. A long time ago, news was delivered once a day. I'm sure a lot of people have stories where their parents would wake up and read the newspaper to see what happened. I used to do that when I was younger. I don't do that anymore. That doesn't make sense. I check Yahoo or Google News maybe once or twice a day when I'm ready and willing to read it. But I no longer have to wait. If something's breaking news, I can go get it immediately. If you wanted to invest in stocks, you used to have to make an appointment. You had to go sit with a stockbroker, call them, discuss what's going on in the stock market and what strategies you wanted them to adopt for you. Now it's instant. There are plenty of websites that you can tell them what strategy you want them to follow, and you just make a regular deposit into their system, and they do the investing for you. You can talk to anybody, anywhere, at any time. There are some exceptions, obviously. People in the space station, it takes a few seconds. You can't talk to people while they're in submarines, but for the most part, you can talk to anybody, anywhere, at any time. Now, technology has gotten into everything. If you can think of it, they can make it, and they will. And that's why we have the Internet of Things. I personally, my phone is attached to my vacuum and my cell phone. I can go into my phone, I can tell my vacuum to clean my house, and it will. I'm not at the point where my phone is connected to my washer and dryer, but you bet your ass, if I had that option, I would. It used to be connected to my dehumidifier, and then I had to get a new dehumidifier, and that made me sad. But your phone is connected to everything. It's no longer just a phone, it's a computer. and it's vital for you to survive. It used to be a luxury, and now it's a requirement. Um, Depending on what kind of car you drive, that car has sophisticated computer systems in it. If you have the fancy version of the Tesla, it will drive for you. Probably shouldn't do that too much, but it will. Uh, it's getting to the point where a computer can guess your health on very little data with relative accuracy, um, better than a doctor can. Not only that, they've found instances where the doctor didn't know what was wrong with somebody, typed their symptoms into Google Chat, or not Google Chat, but into an AI system. The AI system came up with an accurate guess. And this is reaching far and wide. So this is where ethics gets involved. So what I tried to show in previous examples and previous classes and on the exam is if you know you're walking into an ethical issue, you know what to do. You're a smart person. You have a conscience. You do care. Yeah, you're an engineer, so you probably don't express it really well. But you do want to be ethical. But if you don't know you're walking into an issue ahead of time, you might accidentally do something unethical. And that's a concern people have with technology right now. Yeah, the technology has this huge possibility of benefits. Guaranteed, it will improve the quality of our lives, but there are drawbacks. A lot of this technology, for it to work well, needs to know a lot of personal information about you, and that makes you a security threat, unfortunately. I could probably, in the position I have at URI, given your name, could get enough information on you to take out a loan in your name, make you responsible for that loan, but not responsible for how I spend it. Additionally, misinformation gets spread quickly. Though it's beyond the scope of this class to discuss how this works, there are many, many AI systems whose sole job is to post fake news articles, and they're very good at it, and people do believe them. And the last one that I've put here is addiction to the devices. You should probably once a week make an attempt to separate yourself from technology. Because they're starting to find that to a certain extent, some people are literally addicted to their phone. And this is going to have long-term health effects. It causes, if you take certain people's phones away from them, they experience anxiety, similar to if you took cigarettes away from somebody who smoked regularly. So we need to balance this. We want to keep as much the positive as we possibly can while mitigating as much as the negative. And this is a very utilitarian statement. Keep as much of the good as we can, get rid of as much of the bad as we can, and move forward. So why am I talking to you guys about this? Well, when it comes to science and technology, engineers really are the ones that are driving everything. We're the ones that come up with everything. Yeah, scientists, to a certain extent, they figured out the microprocessor, or figured out computers rather, but we're the ones that came up with the microprocessor. We're the ones who made the computer usable, right? So we're going to be the ones that take the software and make the software useful. But in doing that, we have to make an attempt to make sure that it's going to get used in an ethical way. So, like I said, engineers drive technology. They also influence how society uses the technology. And we actually go out of our ways. It ends up being our job to talk to the finance people, the healthcare people, the entertainment people, and tell them this is how you should be using this technology. So what are the ethical implications? Well, first is this is very widespread. Everybody has a cell phone in the US. Everybody has a cell phone in Europe. The only limitation right now is cost. If you can afford a cell phone, you get a cell phone. But because it affects everybody, it has a very high likelihood of having a very negative effect just because it touches everybody. We need to make people accountable. At least, and a lot of times, when you make people accountable, um, they at least try to behave more ethically. And so engineers do need to be held accountable for what they do. You have to make them at least acknowledge what I'm going to do is going to have some long-term effect on people. And I need to make an attempt that this technology either can't be misused, which is hard, or make it really hard for it to be misused. And so we want to incorporate ethical designs into what we're doing. So we're going to focus on medical imaging right now because that's probably going to be the easiest one for you guys to wrap your head around. So AI was introduced to medical imaging in the early 70s. So it was first proposed in the 70s, but they found that it was particularly unreliable. It really couldn't identify broken bones very well. So then in the 90s, things got a bit better. Some computers could accurately detect broken bones, but still not super popular because it wasn't super accurate. The human was still better in the loop than the machine. In the late 2000s, they introduced machine learning and deep learning. And in certain instances, it was better than the human. Today, AI is capable of processing MRI data almost instantly, and it's regularly beating humans in diagnoses. So this is the case. The tale of two engineers. MedTech Innovations is a leading company in the field of medical technology. They've recently developed an AI-powered software that aids in detecting tumors in medical images. Two lead engineers, Alex and Jamie, are responsible for refining and implementing this technology. All right, Jamie, he's a junior engineer. He was thrilled to collaborate with the MD Anderson Cancer Center. He was provided with a data set predominantly composed of late-stage cancer patient images. Using this data and building upon pre-existing AI models, Jamie trained a new model to distinguish between malignant and benign tumors. The results were promising, with the model achieving a 99.5% accuracy rating on its predictions. Alex, on the other hand, despite having more experience than Jamie, seemed to move at a snail's pace. She collaborated with the local hospital, receiving a diverse data set that included images from various stages of cancer instead of jumping straight into training the AI model. Alex spent a considerable amount of time understanding the data, its sources, and its potential biases. All right, Jamie. When it comes to the model validation, didn't really do much. He was enthusiastic about the high accuracy. Jamie decided to conclude the testing phase prematurely. He believed that the model's performance on the training data was indicative of real-world reliability. Unaware of the nuances of machine learning, Jamie didn't use a separate data set, or a separate set of data to validate the model's performance, a crucial step to ensure the model's generalizability to new unseen data. Alex insisted on splitting her data into training and validation sets. She trained her model on one subset and then tested it on the other, a process she repeated multiple times with different data splits. To many, her approach seemed redundant and overly cautious. Her model's accuracy fluctuated between 95% and 98%, never reaching the impressive 99.5% that Jamie achieved. So at this point, I'm going to stop just to give you some background information on AI. So the way it works is you have one big data set and you feed it the data set. And it would be millions to hundreds of millions of photos. And each photo would have key data associated with it called metadata. So if somebody has pancreatic cancer, the only context that the computer would have is this is an image, and this image shows cancer. And would go through thousands to millions of data sets, images like this, and that's all the computer has. This image has cancer. This image doesn't have cancer. And so that when we say models and data sets, it's how does the computer read the image and process the data. Now, there's a technical piece of information here that you need to think about. And you're going to be guilty of this as you're working. You need to test yourself regularly before you show anybody anything. This is a form of checking your work. Alex is checking her work. Jamie is not. Jamie got a result he really liked and he wants to run with it. Alex might have gotten a similar answer at some point in time, but she knew from experience she had to keep testing herself. I'm gone. All right. Peer review and publication. Eager to share success, Jamie sought a peer review of his findings. However, instead of approaching AI specialists or experts in medical imaging, he presented his results to a group of doctors. While they were medical professionals, they lacked the expertise to critically evaluate the methodology and potential bias of Jamie's AI model. Trusting their feedback, Jamie proceeded to publish his findings in a national medical journal with the hospital's endorsement. Alex, on the other hand, before even thinking of publishing, Alex sought feedback from a multidisciplinary team, including AI specialists, radiologists, and oncologists. The process was lengthy, with numerous iterations based on feedback she received. When she finally felt confident in her model, she approached the medical journals for publication. Now, what's going on here? So, in the real world, especially in industry, you always want diversity. Diversity in opinion, diversity in backgrounds. The reason for this is if you go too heavily on one side, it's very easy to miss crucial pieces of information. You'll see as you get older, when you look at academia, they have a nasty habit of reinventing the wheel all the time. And all they end up doing is going into a different field, taking some concept that other field knows really well and applying it to a new field and pretending that it was their idea. That happens a lot. And so what Alex is doing is she knows that she's not really an AI specialist. Yeah, she's a software person. She has all this information, but might be some nuance to the AI that she doesn't understand, and that's why she's going to the AI specialists to get their opinion. But she's also not a radiologist or an oncologist, so that's why she's getting their opinion. Now, in Jamie's case, he didn't go to any AI specialists at all, which is okay, depending on the application, but being that, for the most part, his reports about AI, there should at least be one AI specialist in there assessing his work. You don't want a misguided peer review. The peer review process is designed to catch errors or oversights by presenting to doctors who might not understand the intricacies of AI and diverse training in diverse training data. Jamie missed out on valuable feedback that could have identified potential flaws in the model. All right, so being that this is online, you're not going to be in your groups. I'm going to ask you a series of questions. I'll make sure to put them in the comment section of the link. But the first is for the data acquisition. What are the potential implications of using a non-diverse data set in medical AI research? Why might an engineer choose to test only on training data? What are the risks associated with this approach? How does the validation process impact the reliability and trustworthiness of an AI model? Jamie's model achieved a higher accuracy than Alex's. Does this necessarily mean Jamie's model is better? Why or why not? Discuss or explain the potential real-world consequences of deploying a high-accuracy model that hasn't been thoroughly validated. All right, peer review and feedback. Why is the peer review important in research, especially in medical applications? And what are the potential consequences of not seeking feedback from the right subject matter experts? Ethical implications. Which engineer's approach align more closely with ethical research practices and why? How does personal bias and pressure, the desire for quick results or high accuracy, potentially impact ethical decision making and research? Broader impact. How might the actions of one engineer impact the reputation and trustworthiness of the broader research community? Discuss the long-term implications of releasing a potentially flawed AI model into the medical field. All right. So this is just the conclusion and recap. Um, let you guys read that on your own. All right. Have a good day. Happy Halloween.